आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
The question states, find the current in the wire PQ for the configuration shown in figure. Wire PQ has negligible resistance. B, the magnetic field is coming out of the paper. Theta is a fixed angle made by PQ traveling smoothly over two conducting parallel wires separated by a distance D. So the wires are separated by a distance D, and this is the wire PQ that is traveling inside a magnetic field which is coming out of the paper with a velocity v. So this wire PQ is moving with a velocity v inside the magnetic field. This wire PQ has a negligible resistance, and what do we need to find? We need to find the current that is flowing in this wire PQ. So let's again draw this diagram. Use this, and let's again make this setup, and then we'll have a resistance over here, and then can draw here resistance. And what do we have here? We have a wire PQ in this direction, right? So yes, and then we have angle theta over here, and then this distance is d, plus this is moving with a velocity v in this direction. Now see, if we suppose this is a transverse, then this angle and this angle will be equal. Suppose this line is a transverse and that's dividing two parallel lines, so this angle will also be theta, and it will be corresponding angles are equal when a transverse divides two parallel lines. So let's suppose this is the perpendicular here, and the magnetic field we have is coming out of the paper. Okay. And now this V will have two components. One in the horizontal direction, that is V cos theta, and one in the vertical direction, that will be like this. This will be V sine theta. So from the figure only you can understand it's V sine theta that is helping this wire to move forwards. Okay. And now let's understand what is happening in this magnetic field. So there's a wire PQ. It must have free electrons inside this wire because it's a conductor. So let's consider a 3D structure of a wire that will be something like this. Okay. So this is our wire, 3D wire, and then after it's like moving in the magnetic field, it would experience a force, that is magnetic force. So because of that force, positive charge will reside in one side and the negative charge will reside on the other side. That means if this is P point and this is Q point, negative charge will reside near P point and positive charge will reside near Q point. So when there's difference in polarity of charges, what do we have here? We have electric field. So there will be electric field developed inside this wire. But what is this electric field? This is induced electric field because of this magnetic force. So when this electric field develops, there comes a point when this electric field doesn't allow any further movement of these charges. That means equilibrium is attained. And what is that equilibrium? We say that in that moment, equilibrium when it's reached, we say Fm, that is magnetic force, is equal to Fe, that is electric force. What is magnetic force? That is EVB, right? Charge into velocity into magnetic field. And what is this? E, that is charge into electric field. From here we get E as VB, right? So we got this induced electric field. Now which velocity is helping? V sine theta. So we can replace this V by V sine theta into B. So this is our induced electric field. Now we know whenever a wire moves inside a magnetic field, there is EMF, and that is motional EMF. So that EMF will be given by this. That is E is equal to BLV, right? What is B? That's B, and then V. What is V? V sine theta. and then we have length of the wire, that is PQ. Okay, now see this thing. What is this PQ length? If we drop a perpendicular here, it would be sine theta in this triangle would be perpendicular, that is D, because this distance will also be D, by hypotenuse, that is PQ. So PQ will be D by sine theta. So here we can replace PQ by BV sine theta into D by sine theta, right? Sine theta and sine theta cancel out. So E is equal to BVD. Now we need to find the current. What is current? That is I is equal to E by R. What is E? BVD. And then we have resistance, that is R. So this is our final answer. This is the current that will flow in this wire PQ. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।